All right, so you guys ready to do a whole bunch of conversions? And so again, the conversion factor that we have is we learned previously that 1 degree, right, is equivalent to pi over 180 radians. All right, so that's what we found a little earlier. So going through this, that basically means that I take any one of my degrees and I multiply it by pi over 180 to make my conversion. So 0 degrees is pretty easy, because if I take 0 and multiply it by 180, what I get is 0, right? So in quad number 1, right, 0 degrees as opposed to 0, the only thing missing is the little degree symbol, okay? But it's pretty much the same thing. What about 30 degrees? Well, if I take 30 and multiply it by 180, right, the zeros cancel out, and 3 goes into 18 basically 6 times. So we're talking about pi over 6. All right, so there's the corresponding radian measure for a 30-degree angle. And then going to 45 degrees, if I multiply by pi over 180, again we have 45 pi over 180. And then 45 goes in itself once, and then 45 and 45 is 90, 45 and 45 is 180, so we got 4. So that corresponds to pi over 4. So we've got that one, and that one. 60 degrees, well again, multiplying by pi over 180, right? This becomes 60 pi over 180. The zeros cancel out. 6 and 18 share 6 in common, so we end up with pi over 3. All right, and then last but not least, right, 90 degrees, if we multiply by pi over 180, right, 90 goes in once, there twice, we end up with pi over 2. Okay, so in the first quadrant, going from 0 to 90 degrees, those are basically the radian measures for those special angles. And again, you probably want to start committing those to memory. When you see pi over 6, you're thinking 30 degrees. When you see pi over 4, you're thinking 45. When you see pi over 3, you're thinking of 60. All right, so I'll even put their little in red, right? This was 30 and 45 and 60 and 90. All right, so there you have it. So what about quad number 2? All right, so again, we're going to take all these values. So let's start with the 120, and I'm going to multiply that by pi over 180. This is 120 pi over 180. Clearly the zeros cancel out. 6 goes into there twice and there 3 times. So what we have is 2 pi over 3. Okay, for that guy. And then for 135, let me sneak it up here. Maybe you're going to need some more room. We're going to take pi over 180, right? And so this is 135 over 180. 45 goes into there 3 times, goes in there 4 times, so we have 3 pi over 4. All right, and then 150, we basically have 150 times pi over 180. That's 150 pi over 180. All right, the zeros cancel out. I think what we have here is 3. Let's see what's common. 3 goes in there 5 times and goes in there 6. So we have 5 pi over 6. And then we already know 180, right? 180 turns into pi. So there's your quad 2. And again, what we have, right, this is 120 degrees. This was 135 degrees. This was 150 degrees. And that was 180 degrees. And after just one trial of doing this, hopefully you guys can maybe start seeing a pattern. If not, let me kind of show it, right? Things with a 30-degree reference, quad 1 30-degree reference, and quad 2 30-degree reference. Notice that we're dividing by 6, okay? For a 45-degree reference, we're dividing by 4, right? So 45 reference in quad 2, we're dividing by 4. And for a 60-degree reference, right, in quad 1 and in quad 2, right, that's 120, right, we end up dividing by 3. And since we're just short of pi, notice that, 3 over 3 would be 1, so we're 2/3, 3/4, and 5/6. So we're just short of that. Trying to give you guys a little memory aid. So there's quad 2. So what about quad number 3, right? And so again, let me write the angles. We have 210, we have 225, and we've got 240, and we got 270. And if you're paying attention to what I just said, 210, right, that in quad 3 has a 30-degree reference. So I'm expecting this one to be divisible by 6, right? 225 has a reference of 45, so there's going to be a 4 in the denominator. And then 240 degrees, oops, forgot my little degree symbol, right? That has a 60-degree reference, so I'm expecting it to be out of 3. But let's go do the math, right? So if I take 210 and multiply it by pi over 180, right? That's 210 pi over 180. The zeros cancel out. 3 goes in there 6 times, goes in there 7 times. We end up with 7 pi over 6. So again, that a 30-degree reference usually is divisible by, has a division by 6. 225, right? So 225 times pi over 180, right? This is 225 pi over 180. We're talking 45 degrees, right? So 45 degrees goes in there 4 times and goes into there 5 times. So we're talking about 5 pi over 4. So again, a 45-degree reference, we're dividing by 4. 240 degrees, let me bring it over here. So 240, if I multiply that by pi over 180, we have 240 pi over 180. The zeros will divide out, and then 6 goes into there 3 times, and 6 goes into there 4 times. So we have 4 pi over 3. And again, you can see a 6-degree reference, right, is divisible by 3. And then last but not least, 270 times pi over 180, right? Well, that's 270 pi over 180. The zeros cancel out. I think we have 9, right? 9 goes in there twice and goes there 3 times. So we have 3 pi over 2, oops, over 2. Okay, and you can even see a 90-degree reference angles if you would, right? We're dividing by 2. So those are almost a dead giveaway in terms of that. So hopefully you can see that pattern. So quad number 4, if you're really seeing the pattern, right, let me write these guys down, right? We have 300 degrees, we have 315 degrees, we have 330 degrees, and we have 360. So we already know 360. Right, that is 2 pi, so I'm not going to bother writing that. 300, right, in quad 4 has a 60-degree reference, so I'm expecting a division by 3. 315 has a 45-degree reference, so I'm expecting a division by 4. And 330, oops, forgot my degree symbol, right, has a 30-degree reference, so I expect that to be out of 6. What's the number upstairs? All right, so let's just go look. So 300 times pi over 180, right? So this is 300 pi over 180. The 0 cancels out. 6 goes into there 3 times and goes into there 5 times. So we have 5 pi over 3, right? And so that would be our 300-degree angle in radian mode. 315 pi over 180, right? This is 315 pi over 180. Here we're dividing everybody by 45. So 45 goes into there 4 times, right? And then right here it goes in 7 times. So we have 7 pi over 4. And so there would be our 315. And then last but not least, 330 and pi over 180. This is 330 pi over 180. The zeros again cancel out. And let's divide everybody by 3. So 3 goes into 18 6 times, goes in there 11 times. So we have 11 pi over 6. And so again, one of the patterns you can see, 30-degree reference angles, right, in each quadrant. The radian measure is divided by 6. 45, we're dividing by 4. 60-degree references, we're dividing by 3, right? And then we have, you know, our quadrantal angles that you have to get used to. There's some other little nuances. Perhaps some of you are kind of starting, maybe you can see them, but I think what's down in the denominator is almost a giveaway, whether we're talking a 30-degree reference, a 45-degree reference, or a 60-degree reference. More later, we'll get better, but there's my first, there's our first use of this conversion factor. We converted all our common angles with nice references to their corresponding radian measures, and hopefully we'll use these so much that they'll just become automatic by the end of our year. Obviously, since this is brand new, right, you know, maybe it seems a little overload, but go through some of the conversions like I did and get used to it, get a feel for it. More practice, the better you'll get at it. All right? So there's some conversions. We're going to go practice doing some more things in a moment.